share the screen. And so again, the project is due on Monday. The first homework from this unit is also due on Monday. And we were looking at descriptive statistics. What we are going to do today is add to our knowledge of descriptive statistics. I have that we left off with a frequency distribution, but we did not yet look at the grouped data frequency distribution. And when I look at a group data frequency distribution, what I do is I put the data in classes. And so in order to make a grouped data frequency distribution, I'm going to try to collect some more data from the class. We looked previously at shoe sizes. That's not really that much variability in those numbers to really make grouping seem like a logical step. So what I did with the other section was I looked at the date of your birthday. And so I'd like to go around the group and ask everybody for the date of their birthday. I will write them down and I will share what I get with everybody after. So I'll start. My birthday's on a 13th. Adam, what day is your birthday?
May 7th.
7? Okay, Rachel?
December 22.
Great. Brianna?
August 11th.
Kylie?
February 22nd.
Hussein?
August 24.
Ariel?
December 11th.
Taylor? Taylor, are you there? Taylor? All right, Sonia?
The 28th.
Surianne?
August 25th.
That's my boys' birthdays.
Peter?
April 2nd.
Todd?
Can you hear me? April 2nd.
I said Peter.
All right.
Tosh?
December 24th.
Ooh, Christmas Eve. What fun.
What is the day before?
Yeah. Natalie? Natalie, are you there? Rizwana?
July 22nd.
Oh, wow. We got an awful lot in the 20s. Okay, so now let's see if I can do this. I'll share my screen again. And so the list, ooh, that was weird. I hate minimizing you guys because I like seeing you, but it keeps getting in the way. Okay, so those are the lists of our birthdays. And there's a little bit of spread in there so that we might not want to go through and put each date separately. And so what we might do is for the dates, we might put them in classes. So the first class might be something like the 1st to the 9th. Actually, you know what? I take that back. The first might be like the 1st to the 10th. And the second one might be the 10th to the 20th. And the third one might be the 20th to the 30th. I have a question though.
Me too.
Can anybody see anything that I did wrong?
2,
10 and 20 are both in both categories.
10,
So
20,
21.
Yeah.
supposed
Then
to be
repeat it.
11 to 20.
Yeah.
So is everybody all right? Instead, what I should probably do, I should probably say, over here, let's make note of the fact that the classes should not overlap. And so instead, for our dates, let's do 1 through 10, 11 through 20, and 21 through 30. And then, just like with our regular frequency distribution, it's a matter of personal preference whether you use a tally or just come up with the frequency. Let's go through, because we didn't really write the tally last time. Let's go through and do a tally. So 13 would go here, 7 here, 22 here, 11, 22, 24, 11, 28, 25, 2, 24, 22. So our frequencies would be 2, 3, and 7. When we look at a grouped data frequency distribution, we sometimes discuss the class limits. When we talk about the class limits, every class has a lower limit, which would be the smallest value possible in each class. There's the smallest possible value in each class. So in our example above, our limits, lower limits would be 1, 11, and 21. Does it make sense? Each class will also have an upper limit, which would be the largest possible value in each class. And so in the example above, what would you folks tell me the upper limits are?
10, 20, 30.
Beautiful, 10, 20, 30. Excellent. Oh, I put an extra L in the word upper limit. Sorry about that. We also talk about class widths. And the class width is going to be defined as the difference between two successive lower limits or two successive upper limits. So in our example, what am I going to move back to? In our example, two lower limits that come in a row might be 11 minus 1, which gives me a class width of 10. Or if I wanted to use upper limits, two upper limits in a row might be 30 minus 20, which also gives me a class width of 10. And this one's just a tiny bit counterintuitive because some people look at that 1 to 10 and think, okay, the class width is 9. No, I don't subtract that way. Instead, I subtract this way. The class limit would be the difference between 1 and 11 or 10. So is everybody all right with the grouped frequency distribution?
Yeah. Uh-huh.
The class with upper limits and lower limits have to match.
Yes, it
Okay.
should. If it doesn't, then something's wrong.
Okay. Thank
Okay.
you.
And you don't have to do both of them. You only have to do one of them. I just did it with both to make sure you saw that they didn't indeed match. Okay,
Thank you.
good question. Thanks. So then let's add a page. And next thing we're going to look at are stem and leaf diagrams. Oh dear, I forgot something. I'm going to go back for a second. As I look at this frequency distribution that we made, it's more organized than the list of numbers. It tells us a lot of information. But do you notice when I go from the list of numbers to my frequency distribution, what I lose are the individual data values. The next organizational method that we're going to look at, the stem and leaf diagrams, give us similar information, but we don't lose the individual data. With stem and leaf diagrams, we use them to organize 2-digit data. The stem is a column containing the first or leftmost digit, the leaves is the second or rightmost digit, that's written next to the stem. With these, it's important that you put the stems in order. It's important that you put the leaves in order. And it's important that you include a key. I'm not sure if any of you or how many of you have seen a stem and leaf diagram before. And I think that that work sounds a lot more involved than the process actually is. I'm going to cheat for just a second. And yesterday I learned that I could go through and rather than rewriting all of those, oops, wrong thing. Rather than rewriting all of those, I can go through and it's not letting me do anything right now.
Try Control C and then Control V.
Yeah, I'm just wondering why this isn't reacting to my touch right now, though.
Oh.
Right, we'll do the Control C. The description sounds a lot more involved than what it is. So again, because it's a graphic display, I want to give.
Can you go up a little bit?
Oh, sure. Let me know when you got it all. And we'll look at that before, we'll make sure everybody's got it all down before we start making more. Tell me when you're ready.
All right, I'm ready.
Okay. So let's start making one. Again, because it's a graphic display of data and we want people to know what the data is, it'll be the dates of our birthdays. Now, when I make my stems, I do have a couple of single digit numbers. So we could say that there's like a 0 in the tens place. Then I have some in the tens and I have some in the 20s. So this 0 is for my single digit numbers. This 1 is for my numbers that are in the tens range. This 1 is for my numbers in the 20s. The first number is 13. So that would be 10 and 3. So I'm just going to put the 3 there. The second number is 7. So that would be 07. The second number would be 22. So next to the stem of 2, I'll put another 2 and I'll read that as 22. Then I have an 11. An 11 would be 10 and 1. I'm just going to put that 1 in there next to the 3 because I know
Okay.
everything that's all of these leaves will have a 10 in front of them.
Wait, I don't get it. I
You'll
don't
use
get where
the
you're
comma
putting the
separate?
number.
Okay, so first 13 would be over here, 1, 3, 10 and 3. Then second 7, that's a plain old 7, so that'll be 0, 7. Third number 22 would be 20 and 2. So far, so good. Fourth number is 11. 11 would be 10 and 1. I've already got the first one there for the tens place, so I'm just adding the 1 to the side of it. Any better?
And you don't put a comma between that 3 and that 1?
We're going to talk about that in a minute.
Okay.
Okay. Next number is a 22, so I'll put another 2 next to the 2. Then 24 would be 20 and 4. 11 would be 10 and 1. 28 would be 20 and 8. 25 would be 20 and 5. 2 would be 0, 2. Then I'd have 24 and another 22. Now to the comma question. If you were in a statistics class, statisticians say no commas. Just supposed to be like that without comma in between. So there should be no commas. There should not be commas, but in my labs, they ask you to put commas in. This led to a heated debate once in the math department because Mr. Krupa and Mrs. Jowsey, who primarily teach the statistics class, were both like, why are they having you put commas in? You're not supposed to put a comma in a stem and leaf diagram. However, I think it has probably much more to do with the way the software reads numbers, that in my labs, if you just put the list of digits, it would read it as one long, large number. And so I think it's just like a programming type of thing that in my labs, they ask you to put commas in between. Technically, you're not supposed to. And I guess because of the contrasting directions there, I will accept it by hand, whether you put the comma or not. But technically, they're not supposed to be in there. The other thing, this is my sloppy copy. I need to rewrite it in order. So my good copy would be 0, and then I want to put the leaves in order. First 2, then 7. 1, if I put the leaves in order, I'll have 1, 1, and 3. And then 2, if I put the leaves in order, I have 3 22s, 2 24s, a 25, and a 28. And so this would be my good copy. And have many of you seen a stem and leaf diagram before?
Real?
Not before this class, I would say.
I have.
Some knows. So does it make sense that for somebody who might never have seen it before, I might want to put something like the fact that 1, 1 is equal to 11? So that you have a little bit of an idea as to how to read it.
Do you have to contain a key in our project, or is this just for?
It's just for stem and leaf diagrams. When you do your statistics project and you make a stem and leaf diagram, you would need to put a key in. The other reason that we'd need a key is, well, right now, it's kind of logical. 1, 1 would be 1 in the tens place, 1 in the ones place, which gives me the number 11. But let's say instead of studying the day that people were born on, this was something instead like home values. And if it was something like home values, as opposed to dates, that 1, 1 could mean like 110,000, right? So it would be like, so you need to put a key in there to kind of say what it represents. All right? So
Wait, but how do you get the 11? I didn't get it.
over here, you're just going to grab any number from the stem and leaf diagram and say what it equals. I could just as easily have for my key set, okay, I'm going to say that 2, 8 would equal 28. I'm just trying to grab any number off the stem and leaf diagram and telling somebody what that number represents.
So you don't have to do with each number. You can just do with any random in that
Right.
line. Okay.
Just once for any random number. Now, does this give me the same information that my frequency distribution did? Does this tell me I have 2 groups below, 2 numbers below 10, 3 numbers in the teens, and 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 numbers in the 20s?
Yeah.
Yes.
Yes. What the advantage of the stem and leaf diagram has over the frequency distribution is it gives me that grouped information. But you see, I didn't lose any of my individual data pieces. So that looking at that stem and leaf diagram, could everybody work backwards from the stem and leaf diagram and generate the list of dates?
Yes.
Yeah.
Yes. And so it's a powerful tool for organizing. And actually, if I look at it, once I had my stem and leaf diagram done, wasn't it much easier to organize the leaves in order than it would have been to try to take that original set of numbers and put them in order? So it's a neat, concise way of organizing our data. Sometimes with stem and leaf diagrams, you might see a split stem. Stem and leaf diagram. And I would use a split stem and leaf diagram if I have a very large number of data values. Looking at this, we have what about 12 birth dates, and it looks kind of nice. Instead of 12 people, if there were 100 people, wouldn't the list of leaves get very long?
Yeah.
And so if I had 100 people, I might split my stem so that I have 2 zeros, 2 1s, 2 2s, and so on. And the first 0 might be the numbers 1 through 4, and the second one might be the numbers, I'm sorry, 0 through 4. Second one might be 5 through
9.
9. Then the next one might be 10 through 14, and the next one might be 15 through 19. And wouldn't that, the next one being 20 to 24, and the next one being 25 through 29, wouldn't that potentially cut in half how long any one list of leaves are? Again, I probably wouldn't do that with our data, but if I had 100 people, I might.
Okay.
And then the other thing you sometimes see is a back-to-back stem and leaf diagram. And this might be if you want to use it to compare two different subsets of the population. And so I might have a stem and leaf diagram where my stems are in the middle. And I might put the data for women on one side, and I might put the data for men on the other. And the women's leaves would be off on one side and the men's leaves would be off on the other. And it would be an interesting way of comparing two stem and leaf diagrams by combining them into
You can
one.
go up a little bit.
Sure. Is that far enough?
A little more. Right there.
Okay, hey, do me a favor and just let me know if I'm writing too fast. I can very easily slow
Nah,
down.
you're not too fast. I'm too slow.
And again, if you're having a hard time keeping up with the writing, if you're comfortable with it, you can just pay attention and copy them down later.
Yeah.
Or we can wait, because I also know that when I was a student, if I took my own notes and wrote them by hand, I remembered the stuff better than if somebody just gave me a handout. Which I don't know, are any of you guys like that? If you write your own notes, somehow it helps you remember stuff better than if somebody just gives you a handout with the notes?
Yes.
Yeah.
I figure in my mind, there's two types of people in this world. People who learn better by taking their own notes and people who learn better by just reading the notes. And so in my mind, I thought, well, if I give the notes like this, people who want to write them and that helps them, they can do that. And people who don't want to write them, just pay attention and print them out later because I upload them. So I'm trying to appeal to everybody. But okay,
I'm ready.
enough on stem and leaf diagrams. If so, next organizational tool that we're going to look at, can I turn the page?
Sure.
Yes, ma'am.
Are histograms. There we go. I think I have two styluses and I think one, the battery's dying. And has anybody ever heard of a histogram before?
I don't know.
Yes.
Okay, some yeses, some nos. A histogram is a bar graph,
Oh,
but it's a very particular type of bar graph. It's got some things that has to happen. The horizontal axis must be the data values. The vertical axis must be the frequency. That means that the height of the bars is the frequency. The bars have to have equal widths. The bars must touch. It's important that we label everything. And we need to put a break in the axis if we're not counting from 0. So let me give everybody a minute to take all that down. And then let's make a couple of histograms, one with grouped data and one with not grouped data.
Okay.
Everybody got it, or do I need to wait another minute? We good?
Good.
Okay, we need some data, and so I'm gonna recycle our shoe sizes. And so if I were to make
You mean
that,
birthdays?
oh, is it the birthdays? No, I don't want the birthdays, I want the shoe sizes. So let's undo that. Not letting me. Okay. I thought I had done the shoe sizes already. Birthdays. We didn't use our shoe sizes yet, did we? Okay.
I think we did last class.
Yeah, I have those from last class. So from last class, the shoe sizes were, we had a frequency distribution. And we had 1, 5, no 6s, 1, 7, 3 8s, no 9s, 5 10s, 3 11s, 1 12, and 2 13s. So if I wanted to make a histogram of this, I'd need a title. It would be shoe sizes. My horizontal axis would be my data values, which would be the sizes. My vertical axis would be the frequency. And I could call it frequency if I wanted to, but rather than just calling it frequency, wouldn't it make more sense to the reader if I called it the number of people? You can just call it frequency, but I think the more detail that you can add to your labeling, the more meaningful it is for the person who's reading it. Our highest frequency was 5, and so I'm going to evenly space this. My sizes started at 5. So for this one time, I'm going to be lazy and not. Does everybody remember when you do a graph, where they intersect is supposed to be the 0? I don't want to count up from 0, so I'm going to put a break in my axis. It says I'm skipping from 0 up until 5. And that's what I mean by putting a break in the axis. And then my sizes are 5 through 13. I want to center my bar on the numbers. Now, looking back, because I have one size 5, and I want my bars to touch, and I want to center it. For my bar for 5, it'll have a height of 1, and it'll actually go from 4.5 to 5.5. The bars are supposed to touch, but nobody wore a 6. So it's kind of like thinking that I have a bar of height 0 at 6. Then from 6.5 to 7.5, I'll draw my bar of height 1 for a size 7. Next to that, I'll have a bar of height 3 for a size 8. Again, we had no size 9s. Then we have 5 size 10s, 3 11s, 1 12, and 2 13s. And so it's a bar graph, but again, it's very specific. I apologize, I'm not a good artist. Technically, the bars should be equal widths. They should be centered over the value. The bars should touch. The only time they won't touch is if we have a value of 0. Frequency be on the vertical axis so that the height of the bar tells me how many there are, and the data value should be on the horizontal axis. Instead, everybody got their picture drawn?
Yeah.
Instead, if I wanted to do a histogram, for grouped data, there's a couple of ways that you can do it. I think probably the neatest way is to label the axis with our either upper or lower limits. I'm gonna go in and use our swipe our birthdays again.
Okay.
So this one will be birthdays. Our data is the dates. Our frequency is the number of people again. If I remember correctly, we had, I think, 7 people in the 20s, so I'm going to label this up to 8. I'm going up to 8 just because I find 8 an easier number to divvy up evenly. Oh, I should be putting those labels on the other side. And so this will be my 0. And then I'll just label with the next limits, 10, 20, 30. And we had 2 people with birthdays before the 10th. We had 3 people with birthdays between 10 and 20. And we had 7 people with birthdays between 20 and 30. I'm going to move this label down a little bit so it looks neater. And so I've got my grouped data. I find labeling it this way just looks a little bit neater, yeah? Looks a little bit more organized. Some people instead will write underneath here something like, some people label that as like 1 through 9, and some people would label that like 10 through 19, and some people will label that like 20 through 29. But I don't know about you guys. I think just putting those lower limits there gives that same, I'm sorry, yeah, those
Yeah.
limits there gives the same idea, but looks a little bit neater. You can do it either way, but we can do a histogram for our grouped data.
Okay.
And I want to go a lot further, but I'm looking at my time. I
Yeah.
think we're supposed to be ending class now. And
Mhm.
so, does everybody have this?
Yeah. Got it.
So I'm going to stop here. And I'm going to stop sharing my screen. I'm going to stop recording.